Hello everyone. In today's session we will be learning about conditional codes that we see in our ARM language. Okay, so first of all we need to know what exactly is a conditional code. Conditional codes are nothing but two letter suffixes which we add to instructions to tell the CPU when to execute them. Okay, and all this is done based on the result of previous operations. Okay, so before this we should have some knowledge about CPSR register, because all these conditional codes work based on the content of CPSR register. Okay, I have made a separate video on the contents of CPSR register, so you can know more about it over there. Okay, so let's just see the content of CPSR register here. Okay, if you notice here we can see N, Z, C, V flags. Okay, so these flags are updated based on the result of previous instruction. Okay, that is, let's assume result of any instruction is negative, N flag is set. If result is 0, Z flag is set. If a carry, that is nothing but an unsigned overflow, or if there is no borrow generated in the previous operation, then C flag will be set. And lastly, if there is signed overflow, V flag will be set. Based on these particular flags, that is nothing but negative, 0, carry and overflow flag, our conditional codes will work. Okay, and if you want any instruction to update these flag, we have to use a suffix called yes after that instruction. That is, if there is an instruction called move, then we have to use a command move s in order to save the contents of CPSR register or to update the register content. Okay, we need to use the term s, which will set the conditional flag. Or other cases, if we use instruction like compare, which automatically sets the conditional flags. So once the conditional flags are set, after that if we use these conditional codes, in that particular case it will check these contents, and based on that it will either perform that particular instruction or it will just get ignored. Okay, now let's see what exactly is happening here. In this particular session I'll be considering all those conditional codes which will directly check one particular flag, and based on that it will either execute an instruction or it will not execute an instruction. Okay, let's see what exactly is happening here. These are nothing but assembler directives: Z flag, N flag, C flag, and here V flag. All these are nothing but labels. Okay, you can give any name there. Okay, now let's just execute our code and see what exactly is happening. So let's start with the first case. The very first instruction that we are taking here is move r0, #7. Okay, so if you notice here we have r0, and that is now loaded with the value 7. Next we have the instruction r1, #5, and r1 gets the value of 5. If you see here, I have not used 0x or something like that. Okay, if you directly use the number hash and some number, it is nothing but it will take the decimal value. If you use 0x and if you write any number, it will take the hexadecimal value. Okay, you can take any number here. I am just randomly taking from some values. Okay, next what we have is comparison. R0 and R1 is compared. One thing you should know about CMP or compare instruction here is internally it will perform subtraction. It will do R0 minus R1 and automatically updates the contents of CPSR register. Okay, only compare instruction we will discuss, which automatically updates everything. If in case you are using any other instruction and you want CPSR to be updated, in that particular case you have to use the suffix yes. Okay, so I told internally subtraction happens. 7 minus 5, result is nothing but 2. Okay, and as you can see, in order to give information that I'll be checking only Z flag here, I have written the label as Z flag. Okay, so we have two conditional codes here, EQ and NE. These both will only check the Z flag or the 0 flag. See what happens here is nothing but in this particular command it will check move if equal R3 comma hash 1. What it is saying is nothing but it will check if Z flag, if this flag is equal to 1, in that case R3 should be equal to 1. And move NE is nothing but not equal. If Z flag is not equal to 1, in that particular case R3 should be set as 2. Reason is when R0 minus R1 is carried out, result can be 0 or any positive number or any negative number. If the result is 0, in that case this condition equal becomes true. If that particular result is not 0, then not equal becomes true. And this checking is done only with respect to Z flag. What values are set in N, C, V flag, it is irrelevant here. Okay, so if Z equal to 1, it means move equal is true. If Z equal to 0, it means move not equal is true, because of which in this particular case this particular statement will get executed and this will get ignored. Okay, so you can see that if this is executed, R3 was supposed to have a value of 2, so we can see that answer being here. Okay, so let me just change it now. Okay, in what case would this condition be true? If EQ condition be true, that is if R0 and R1 had same value, 5 minus 5 would be 0, that means Z flag would be 1 and EQ would be true. Now let's see that particular condition. R0 value is loaded as 5, R1 is 5 and the result of that is nothing but 0, because of which Z flag is set as 1. So obviously this particular command will be executed. Let's see how it happens. R3 is now stored as 1. And what about next command? It will get ignored because this particular condition is false. So here any particular command is executed only if the condition which is put in front of it is true. Okay, if no condition is written, like for example move R0 comma hash 5, any condition is not written here, it is equivalent to writing move AL or move always. Okay, in other words, this particular statement should be true or should be executed in all the cases. Okay, so let's go to the next case, which is about the N flag or negative flag. N flag checks whether result is negative. Okay, if you consider the first value as 7, second as 9, you know comparison is subtraction internally, but it will not generate a result, it will just update the flags. Okay, so 7 minus 9 is actually, it is nothing but minus 2, which is a negative number. Immediately N flag will be set as 1. And based on that, these two instructions will be executed, mi which is minus and pl which is plus. If result is negative or if the result is minus, in that particular case move operation is carried out in this case. If the result is positive, in that particular case this operation is carried out. But we can clearly see 7 minus 9 is nothing but minus 2, because of which when you consider the next case, okay, you see that the comparison generated a negative value, that is nothing but N is nothing but set as 1. So Will the next instruction be executed? Yes, it will be executed because the result is negative. What about this particular instruction? This would be true if the result is positive. So this will get ignored. Okay, so if required, I can just change the value here. Okay, so now we have taken the first value as 9 and second value as 7. In this comparison result, if you check, it is 0. Okay, because of which, is the first condition true? No, it's false, because this will only be executed if minus value was there or negative value was there. But will the second instruction be executed? Yes, it will be executed because the previous result was positive. Okay, next we'll be considering the C flag or carry flag. Okay, let's continue here. R0 is 4, okay, and R1 is 5. If in case, okay, if you consider here 4 minus 5, if you write 4 minus 5, okay, there will be a borrow generated, correct? Normal subtraction, okay, because 4 is less than 5, a borrow is generated. Whenever a borrow is generated, carry is automatically 0. Okay, carry and borrow are opposite terms. Okay, if a borrow is generated, carry is 0, and if carry is 0, here the command itself says carry clear. Okay, this will be set. But if in case borrow is not generated but there is unsigned overflow, in that particular case carry is set. Okay, now let's see what is happening here. Okay, so we will see that comparison is done, and after comparison carry is 0 because there is a borrow generated. Okay, so we will consider the next step. See, move if in case carry is clear R5 as 5. Okay, so this gets the value of 5, but is the next condition true? No, it's all the conditions I have taken are exactly opposite to each other. If this is true, this is false. Okay, so that gets ignored. In what case we will generate a carry here? Here we are taking reverse values. Okay, so R0 is now 5 and R1 is 4. Now if you compare, obviously internal subtraction 5 minus 4, there is no borrow. Whenever there is no borrow, specifically in subtraction, okay, immediately carry will be set as 1. Okay, this is one thing you should know, that whenever there is no borrow, when you compare two things, immediately carry is set as 1. Okay, one more case is when there is an unsigned overflow. If you take a very big value here and perform addition also, in that particular case also you will get a carry flag as set. Okay, so if you notice here, if carry was 0, R5 would be 5, but R5 is 6 because now carry is set. Okay, let me even show you that example. Okay, so now R0 is a very high value. Okay, and R1 is 1, but what I'm doing is I'm performing addition here. Okay, if we check the flags here, okay, addition will result in a carry because a very large number is added with 1. Okay, overflow actually means the given area is not enough to accommodate the result. Okay, that is nothing but unsigned overflow happening here. Fine, the max number that can be stored here is f. Okay, plus 1 means it will generate a higher value which cannot be stored in the given register. Okay, so for this also carry gets generated. Okay, so let's consider the next case, that is overflow, but this is signed overflow. There is minor difference. Signed overflow means when you consider unsigned, we think that number starts from 0. Okay, 0 to all positive numbers are only considered, but if you are saying signed means it includes positive, negative numbers. Okay, and in if you consider signed numbers, maximum number possible is 7 f. Okay, fine, there is no number more positive than this particular number. This is the most positive number. If you add 1 to that, again that generates a overflow, but that is a signed overflow. The overflow generated in previous case was unsigned overflow. Okay, let's see what is happening here. Let's focus on the CPSR content, and you can see overflow is generated. Okay, so that is overflow is set here. So in what case do you think, and because of which the result of R6, okay, I will see that is 8 as per our instruction. In what case overflow will be clear or overflow will be 0? Perform normal addition. Yes, here what is happening? We are performing a very small addition, 2 plus 1. Hexadecimal or decimal doesn't matter. Result is 3. So that will not cause any problem. Okay, all flags gets updated. Everything is 0 only. Okay, because neither result is negative, neither Z flag is true because the result is not 0. Carry is also not generated because it's a very small addition, and overflow flag is also 0 here, because of which this particular condition is executed. Okay, and I think one thing we should always know is, in case of signed overflow is generated, then overflow flag is set. Unsigned overflow is generated, carry flag is set. One more condition where overflow is set is specifically in case of subtraction. Now this is addition. Okay, in case of subtraction or comparison operation, because internally in both the case subtraction only happens. If there is no borrow, then also carry will be set. These are few things we should remember, and based on which we can know which flag is set and which flag is cleared.